What was the last topic we discussed?
Petroleum. In petroleum we are discussing.
Petroleum we are discussing. So petroleum refining, how to refine we are discussing, right? Yes. Okay. Is this?
Yes, sir.
So this we discuss that extraction of petroleum. So petroleum is present under the oceans and under the earth between the rocks, and we can take that petrol by drilling. Okay, by using the drilling machines, we drill the ground, we drill the earth, and then we can take the petroleum. So petroleum is nothing but a crude oil. What it is? Crude oil. Crude means what? Which is a mixture which is a mixture of so many substances. So that is called as a crude oil. Okay, so petroleum is a dark oily liquid. Can you see how it is flowing? Okay, can you see this picture? If you play the water pen stuck, water will fall immediately, but you see here how it is falling slowly. It is falling, yes or no? So this is a dark oily liquid. It's look like a oil. Okay, so dark oily liquid and has an unpleasant odor. Unpleasant means what? Its smell is not good. Okay, and it is a mixture of so many substances like hydrocarbons. Okay, so a mixture of various constituents such as petroleum gas, petrol, diesel, lubricating oil, paraffin wax. So many things are there, all are mixed together. So that is called crude oil. And if this crude oil is taken and if we refining it, okay, then if you means what, if we separate them, then we can get to so many things from that. Is this clear to you? Right? So here this is very important. Here, refining of petroleum, the very important definition, this one, the process of separating the various components of petroleum from one another is known as the refining of petroleum. So petroleum is a mixture. It consists of kerosene, petrol, diesel, gasoline, okay, what is this, paraffin wax, lubricating oil. So many things are present. So we have to separate them, okay, individually, whatever we want. So this process of separating all the components from this petroleum is called refining. What is the refining? So see a definition, read the definition loudly.
The process of separating the various components of petroleum from one another is known as the refining of petroleum.
Very good. So that is called refining of petroleum. Okay. So during refining, how can we separate? Okay. So we can separate all these substances, all these components by the process called fractional distillation. Which method?
Fractional distillation.
Fractional distillation. So this fractional distillation is what? So this is mainly based on the difference in their boiling points. So we separate difference in their boiling points. Okay, so means what? Kerosene and petrol both are okay, components of petroleum only, but they have the different boiling points. And petrol and diesel, you see, these are also components of petroleum only, but here also it have the two different boiling points. So based on these different boiling points, we can separate them, okay, by using the method called fractional distillation. Very important thing, this you have to remember. So where is the fractional? Okay, so this is done by the process called fractional distillation. So fractional distillation is what? It's based on the fact that different components of petroleum have, okay, distinctly different boiling points. See, this is most important. Okay, fractional distillation can be done if you want to separate any, okay, mixture of two substances, means two liquids. Okay, if there is a difference in their boiling points, then we use fractional distillation. Is this clear to you? So, for example, you see, normally also, for example, you think like water and alcohol. For example, you think water and alcohol, two things are there. Alcohol and water we both mixed together, you think. Now both are liquids only. Okay, alcohol also look like a water, and water is also water. So here both are look like and both are mixed thoroughly with each other. Can we separate them by using the filtration? No. If we filter both are liquids, so liquid will, okay, we cannot separate them. So to separate them, then what we use? We use the fractional distillation method, because here the water boiling point is 100 degrees and alcohol boiling point is about 76 degrees Celsius. So one is 76, one is 100. So there is a difference in the boiling point of these two. So by using this difference in the boiling points, we can separate by using the method called distillation or fractional distillation. Okay, so read this point once loudly.
This is done by a process called fractional distillation, which is based on the fact that the different compounds of petroleum have
Distinctly different boiling
different
points.
boiling points.
So in this so many compounds are there, and all compounds do not have the same boiling point, they will have different boiling points. Okay, so based on this concept, okay, so this concept is used in separating these, okay, components of petroleum. So for that what they do is, first step is, okay, in fractional distillation, crude oil means crude petroleum is heated up to 400 degrees Celsius. How many degrees Celsius? 400 degrees Celsius. So slightly above in the furnace. So what happens at this temperature, this okay, petroleum will be converted into the vapor. Vapor means what? Like gaseous state. It is in liquid state now. So see, it is in liquid state. So now this is heated above 400 degrees Celsius. So what happens? Now this liquid will be converted into water. Gaseous state means what? Sorry, vapor. Okay, it converted into vapor state. Now this vapor state, okay, this vapor is sent into the tall tower. A very big tower will be there. Very tall tower is there, and in that tower has so many fractions. Okay, okay, shells are there, and at that shells different temperatures are maintained. I'll show that this. Okay, so see here. Yeah, this, instead of this we go to this picture. Yeah, this picture we go, and then we go to there, okay, in the previous, right? So this is the fractional distillation will be done here. See this picture you see, okay? So this picture, this is called fractionating tank, okay? This is called fractionating column or fractionating tank. It's a very big tank, very tall tank, okay? Very big tank will be there, okay? And here you can see so many fractions are there. See, here it is one like this. So they divide into so many parts. Can you see here? Okay, like this, right? Now here they maintain different temperatures. Here see 370 degrees Celsius. Here you see 300 degrees Celsius. Here you see 200. Here 150. Like this, as we go, okay, top. Okay, then what happens? The temperature will be decreases. Okay, the temperature will be decreases. So first what they do is, first they will take the crude oil, this is a crude oil, and heat it. See, crude oil, and is heated up to 400 degrees Celsius. How many degrees Celsius? 400 degrees Celsius. At this 400 degrees Celsius, what happens? Most of the crude oil means petroleum will be converted into vapor. Converted into vapor. So this vapors will move up. Okay, so see here gaps are there now. So through these gaps, okay, through these gaps, now what happens? This vapor will move up. Now all these vapors enter into this tank, this part. Can you see here this part? Okay, here. When you come to here, so what happens? The temperature is decreased. It decreased from 400 to 370. Okay, temperature is decreased. See, when the temperature is decreased, okay, then what happens? Gases can be condensed. You know this condensation process? For example, water is there. So water, if you convert the water into water vapor, so when the water vapor condenses, again it converts into liquid. Do you know this one? So here also what happens here? Here all the vapors are going above, from that vapors, some of the vapors, okay, when the temperature decreases, they get condensed. Condensed means what? They convert into liquid. Are you following? Some of the vapors they will be converted into liquid. So this liquid, okay, which is converted into liquid, that liquid will be taken out from here. So here you can see your opening is there. Can you see here open? Okay, through this opening it comes out. And what is the gas condenses here? That is called fuel oil. What it is called here? Fuel oil. So in the so many compounds are there. In that one component is converted, means one component is separated as a fuel oil. One component only separated as a fuel oil. Is this clear to you? Now here only I said, only some vapors only converted into liquid, means condensed. Condensed means what? Converted into liquid. And remaining vapors what happens? Again still they go up. Now still what are the vapors are there? These vapors are going into the next fraction. Can you see here? They are going into the next fraction. Okay. Now there what happens? Still the temperature is reduced. Still the temperature is reduced. So see here how much temperature here? 300 degrees only. So temperature is decreased. Now what happens? So vapors which are going into second fraction, from that some of the vapors get condensed now. Now because temperature is decreased, so some of the other vapors will get condensed here. So when they condense, what happens? They convert into liquid. Yes or no? So now, so here some of the gases, means some of the vapors will condense here, and that will be converted into liquid, and this liquid flow from here, and when you collect this liquid, then what we get here? Diesel we get. What we get here? Diesel. We get the diesel. Okay. Now in this way we are separated one more component also. So in the first we are separated fuel oil, and in second we are separated diesel. Okay. Now still some vapors are there. These vapors, now whatever the vapors which are not condensed, still they go up. Okay, still they go up like this. So here you see, now they are going into the third column. Now what is the temperature of the third column? 200. Means what? Still temperature is decreased. Yes or no? So still when the temperature is decreased, some other gases, means some other vapors now condensed. Okay, so some other gases will be condensed here, and that will come. Okay, condensed means what? They convert into liquid. Now they will come here. This all will be collected here. Then what will get here? Kerosene. So like this kerosene will be separated. Okay. So now we have separated three: fuel oil, diesel and kerosene. Still the vapors are there inside, and those vapors still they are going up. So some of the vapors are still they going up, see like this. Okay. So when they are going, what is the temperature there? 150 means what? Still the temperature is reduced. Still the temperature is reduced. So what happens? Some other gases again they get condensed. Some other gases will get condensed. So condensing means what? Converting into liquid. So these gases will be collected from here. So converted into liquid. Liquid is connected. Okay, collected here. Now what is the liquid we get here? Petrol we will be getting. Okay. So 1, 2, 3, 4 are collected. Like this it's going up now still. Okay. After still some gas will be going. Like this different temperatures are maintained as they are moving upwards, so the temperatures are reduced. If the temperature is reduced, what happens? Some of the gases will be getting condensed. Condensed what? Converting into the liquid. So those will be separated, so that we will be getting, okay, like this so many compounds will get. This is called fractional distillation. This method is called what? Fractional distillation. Is this clear to you now? Fractional distillation, how it will be done? So very simple. So first they take the crude oil, and the crude oil first it is heated up to 400 degrees Celsius. So most of the crude oil will convert into vapor, but some of the crude oil will not convert. So that will be remaining in the liquid state only. That liquid state here collected at the bottom here. So this is okay, used for a lubricating oil, paraffin wax, asphalt, like this chemicals are prepared from uncondensed, the gases which are not vaporized. Is this clear? So petroleum crude oil is taken, and that is heated up to 400 degrees Celsius. So most of the liquid petroleum is converted to gases, means vapors, and these vapors will be going into the fractionating column at a different steps, different heights, different temperatures are maintained. As you are moving above the heights, so what happens, the temperature will be reduces. At this different heights, different components get condensed, they get cooled, and they convert into liquids, and those liquids are separated. In that way we can get various fuels will get, like fuel oil, diesel, kerosene, petrol, and still if you go finally what will get, butane and propane. And butane and propane, where we use mainly in LPG gas we use. Where we use these gases? LPG, liquefied petroleum gas, whatever the gases our mom is using, so there will, this gas will go. Is this clear to you? So this is about the fractionated petroleum. So now you see, once again we discuss here. So fractional distillation is a process by which oil refineries separate crude oil into different, see, they are separating, the process of separation of crude oil into different more useful hydrocarbon products based on their relative molecular weights and distillation tower. And the different components that are separated out during this process are called fractions. What are the fractions? What we are getting through this, in this, what we are getting here, this petrol we are getting, kerosene we are getting, diesel we are getting, fuel oil we are getting, butane and LPG gas we are getting. These are called fractions. What they are called? Fractions. Now they are called fractions. So these are called the different components, important ones. See, this is important sentence. So the different components that are separated out during this process are called fractions. Now this fraction distillation allows a lot of useful products, a lot of useful products to be made from the crude oil with many environmental consequences for the use of useful products. So like this we can get so many useful products we get. Fractions that are separated out are include gasoline, diesel, kerosene, bitumen, like this, so many things we can get here. So here also, this also same picture. So here you can see fuel oil. So where we use the fuel oil, here we are using the fuel oil and bitumen and lubricants and paraffin waxes and diesel oil in the vehicles, kerosene of course in the lighting, and this one gasoline we are using the aeroplane, and petroleum gases we are using the industries. Like this various fractions, various components what we separate, these components are called fractions. What they are called? Fractions. So like this we can get various components and they can be used, so many things we can use. See, so many useful products are there, you can see here. Fraction distillation also a lot of useful products. Lot of useful products, so many things for we use this all. Is this clear to you? So first take the screenshot of this one. Then next screenshot also you can take, this also you can take. Now see here, now once again we discuss this one. So see here, process, what is the process, how can it, what I explained here, the same thing it will be there here. So see here, the process of fractional distillation is fairly simple, but it is very powerful. Powerful in the way that it separates all the different complex compounds from the crude oil. So this fractional distillation is looking like very simple, see here, very easy, but it's a very powerful method to separate the so many components of petroleum. First the crude oil is heated. See here, there is a crude oil. So first the crude oil is heated to vaporize. Vaporizing means what? To convert into the vapors, gaseous state, and it is fed into the bottom of the distillation tower. Now it is fed into the bottom of the distillation tower. This is distillation tower, bottom means what? Down. Now the resulting vapor then rises through the vertical column. So now these resulting vapors are going, rises means what is going through the vertical column. So like this they are going. As the gases rise through the tower, the temperature decreases. Here 400, 370, 300, 200, 150, 20, like this. As it rises, as the gases rise through the tower, the temperature decreases. As the temperature decreases, certain hydrocarbons begins condense and run out of the different levels. So at this temperature, some of the hydrocarbons will condense, means convert into liquid and run like this. So we can separate them. From here the diesel get condensed, we can separate them. From here petrol we can get, so kerosene like this. Okay. So as the temperature decreases, certain hydrocarbons begins condense and run out of the different. Each fraction that condenses of at certain level contains hydrocarbon molecules with a similar number of carbon atoms. Okay. So this is about the this one. I have taken the screenshot of this one also.
Yes.
Chalo. Right. Now see here, this is cracking. Okay. So this cracking actually you learn in very higher classes, not even 11th and 12th standard also. You will be learning in higher class actually what is a cracking process. Cracking is nothing but the breaking of a bigger molecules or higher molecules into smaller molecules or simple molecules under high temperature and pressure. Under high temperature and pressure in presence of catalyst. In presence of catalyst is called a cracking. Okay. So I think the definition is looking complicated, no? So very simple, complicated it's not. For example, a big things are there. We want to make it a small things. So what we do? We apply the force, pressure and temperature. Okay. So under high pressure and temperature, we can break the bigger molecules into smaller molecules. Okay. In presence of catalyst, this process is called cracking. Is this clear? Cracking means?
Yes.
What once you say, what did you understand about the cracking?
If we want to crack the big things in small pieces, we use this process.
Under high pressure and temperature in presence of catalyst. This is most important. You have to say like in presence of high temperature and okay pressure. Okay, in presence of catalyst is called cracking. So cracking means nothing but a breaking of a bigger molecules into simple molecules, smaller molecules. Okay, that's called cracking, and cracking is one of the best method. Okay, which is used in the petroleum process. Okay, in separating, in refining means purifying, and sometimes even artificially also we can prepare this one. Okay, so you see here, after this rough refinement is what? This one, this is rough refinement. Okay, after this rough refinement, individual fuels may undergo more refinement to remove any contaminants or undesirable substance, or to improve the quality of fuel through the cracking. So when you separate like this in the previous process, whatever this it may contain some undesirable substance. Undesirable means what? Unwanted. Okay, such unwanted substances are maybe present in that. Okay, so if you want to remove that and we want to make it pure, okay, so we want to improve the quality of this one. For that purpose we use cracking. So cracking in petroleum refining is, see, this is very important, the process by which heavy hydrocarbon molecules are broken into lighter molecules by means of heat and usually pressure and sometimes catalyst. This is the definition actually what I said. Okay, so making of a bigger molecules into simple molecules, like small molecules under heat and pressure. Okay, sometimes we use a catalyst also. What is mean the catalyst? Do you know what is mean the catalyst?
No.
No. So catalyst means what? Which promotes the rate of reaction. What is the catalyst definition? Which promotes the rate of reaction. Means, for example, sometimes reaction may not takes place quickly. Okay, in such places what you do, we add the catalyst. So catalyst helps us to take the reaction fast. Okay, so which promotes means what? Which helps in taking the reaction fast, that are called a catalyst. Is this clear to you? Sometimes we need to complete one reaction, we need lot of heat we require, you think, large amount of heat. So for that large amount of fuels also we need. So if we add catalyst, what they do, they help us okay, to take the reaction at a low temperature only. They help us to take the reaction at a low temperature only. So they are called a catalyst. Catalyst means what? Which promotes the rate of reaction. Which promotes the rate of reaction. Okay, so that is called a catalyst. Okay, so that is catalyst. So here the process by which important thing is this one here, heavy hydrocarbon molecules. Heavy means what? Bigger. Okay, are broken into lighter, see, broken into lighter molecules in presence of heat, pressure and catalyst. This is called cracking. Is this clear to you now? Cracking means, okay, so bigger molecules we are breaking into smaller molecules by pressure and heat in presence of catalyst. Okay, so cracking is the most important process for the commercial production of gasoline and diesel fuel. So to get the pure gasoline and diesel, okay, so quality of diesel, if you want to improve the quality of diesel and gasoline, then we use the process called cracking. Okay, and cracking process will be like, okay, it will be like this. So this is a simple okay, picture it is given. So in this picture, okay, by steam, so this is very hot and under pressure. So then what happens here, you can see a C16H34, see, bigger molecule, 6 carbon atoms are there and for 34 hydrogen atoms are there. They are breaking into C8H18 and C8H18. Okay, so like this, bigger molecule is broken, means one molecule is broken into two simple molecules. So this process is called a cracking. Is this clear? Cracking.
Yes.
Chalo, take the screenshot of the cracking also. Done. Chalo. So with this the petroleum is done. So now where we use this petroleum, which component and where we use. Okay, so we discussed that on refining of petroleum we get so many components like petrol, diesel, kerosene, gasoline, okay, and LPG gas, like this, so many things we get. So where we use this, okay, all things that we are going to see here in this chart, this is also very important. So petroleum gas in liquid form, so that is called LPG gas, liquefied petroleum gas. Where we use it as a fuel for homes and industries. In our homes we use the LPG gas only, liquefied petroleum gas, so homes and industries. Then come to the second fraction is what? Petrol. So where we use the petrol? Petrol as a motor fuel, aviation fuel. What is with the aviation?
In this fuel.
Flight. Aviation means water.
Light.
So there, and solvent for dry cleaning. Do you know what is with the dry cleaning?
No, sir.
No. So for example, okay, any costly clothes are there you think. For example, your mom is there. So your mom wear the pattu chira. You know the pattu chira, silk sarees?
Yes.
Did you see any time they washing the silk saree?
Yes.
No, they don't wash the pattu saree. Okay, once you ask your mom later after the class. So they don't wash this pattu sarees, okay, the silk sarees, you know. So then if they wash, that may spoil. So that's what they do is, they will give to the dry cleaning. Okay, so dry means what? Not liquid, okay, dry, you know, not dry cleaning.
Yes.
So dry cleaning, so by using the petrochemicals, okay, but they remove all the dirt from the clothes. So this process is called dry cleaning. Okay, so dry cleaning, they don't wash the, okay, clothes, like, you know, pattu sarees, I said, no, silk sarees, and like this blazer. If your dad is wearing the blazer, so I think the blazers also generally they don't wash normally. Okay, if you wash, they get spoiled. So these also will be given like a for the dry cleaning. Okay, in the dry cleaning, petrochemicals are used, okay, to clean or to remove the dirt from the clothes without washing. Is this clear to you?
Yes.
Right. Then come to the kerosene. So kerosene, you know that kerosene is used as a fuel in stoves, lamps and jet aircrafts. Right. Diesel, you know, diesels are used in the heavy motor vehicles like bus and lorries, and in electric generators also they use. Lubricating oils, for lubrication in the bikes and vehicles also they use the oil. Do you know? For more lubrication, engine oil like this will be there. So they use for lubrication, means what? To softness, to reduce the friction, next, paraffin wax, you know, this is used in the ointments, candles, vaselines, etc. And bitumen, already we discussed about bitumen, they in the paints, roads, surfacing like coal tar. So these are the constituents of the petroleum and their uses. Clear?
Yes.
Chalo, take the screenshot of this one.
Taken, sir.
Chalo, with this the topic is done. Now this topic you read and explain to me.
Uses of petroleum.
Ah.
Petroleum products are used as fuels. And lubricating oils and Vaseline are used as lubricants.
Lubricants means what? For reducing the friction. Okay, so that's called lubrication. Yes, yeah, next.
And
Paraffin wax.
paraffin wax products of petroleum is used for manufacturing candles, polishes, waxing paper, waterproofing, etc.
Very good. Next.
Some of the byproducts of petroleum after purification are used in preparation of medicines, ointments, face creams, and
And cosmetics. Cosmetics means what?
I don't know,
Which improve the appearance of the person. Which improves the
appearance of a
so which comes under cosmetics means fair and lovely. You know the fair and lovely?
yes, sir.
Face powder, you know.
Yes, sir.
Lipstick, you know.
Yes, sir.
Nail paints, you know.
Yes, sir.
This all comes under the cosmetics. This all comes under what?
Cosmetics.
Cosmetics, which improves the, okay, what is it? Attraction. Okay, so that is called as cosmetics. So in the cosmetics, ointments, face creams, medicines, in all these places also they use. These all are the uses of petroleum. Clear till here?
Yes, sir.
Yes. So with this topic is done. Now the last and final topic, that is what? Solar energy. Right? One solar energy is left. Tomorrow we discuss about the solar energy. With this chapter will be done. Okay? Okay then. Understood everything? So this all very important. This all you cannot find in your textbooks. So that is IIT. So we are giving some additional knowledge. This all we can find in the 11th and 12th standards, and where you can give, okay, helps in cracking the IIT. So that's what this all you have to learn. Very important things are here. So many things you will get in the IIT main exams. Is this clear to you?